An AI sees 1,000 cat photos, yet nobody ever tells it what a cat is. Inside lives a network of tiny math units, loosely inspired by neurons in your brain. Each connection has a weight, a number, deciding how strongly one signal influences the next. At first, these weights are random, so the AI's very first guesses are basically nonsense. We feed it an example and let it predict, then compare its answer to the truth. The gap between guess and reality is the error, and shrinking it is the whole goal. Imagine the error as a vast landscape of hills, and we're hunting its lowest valley. To descend, the AI checks which direction the slope falls most steeply right now. That clever slope-finding trick is called gradient descent, the beating heart of machine learning. Each tiny step nudges every weight a little, lowering the error one careful move at a time. The error signal flows backward through the layers, telling each connection how to improve. Engineers call this backpropagation, the way errors get fairly blamed across the whole network. Repeat this loop millions of times, and the network slowly sharpens into real competence. Now patterns emerge, edges, then whiskers, then the unmistakable shape of a cat. But beware overfitting, memorizing examples instead of learning the general idea behind them. So we test it on fresh, unseen data to prove it truly understands. Learning is just this: predict, measure error, adjust, repeat until the mistakes nearly vanish. AI learns by failing smarter each time. What should Bolt explain next? Tell us below.